In this class, we are going to discuss about the single phase full wave semi converter with RLE load, discontinuous load current. To explain the circuit, we have taken the two voltages VAB and VBA as input voltage. Alpha and pi plus alpha, we are applying the triggering voltage to the SCR1 and SCR2. Again, 2 pi plus alpha, we are applying the triggering voltage to the SCR1 and SCR2 at 3 pi plus alpha. Now we are going to develop the output voltage waveform from alpha. At alpha, SCR1 is on and D2 is already forward bias. So there is a closed path between the load and the supply up to pi. After pi, T1 is forced to conduct because of this inductance. After pi, the input voltage also will be reversed. With that reverse polarity, the D2 is off whereas D1 is on. In the same leg, the T1 D1 is conducting. So the freewheeling action taken place. The output voltage 0 up to beta. At a beta, the T1 also will be off. Once the T1 is off, there is no closed path for the load. So the load voltage is equal to E up to pi plus alpha. At a pi plus alpha, T2 is on. Once the T2 is on, there is a closed path between the load and the supply through the T2 and D1 because already D1 is forward bias with the input voltage. The output voltage follows the input voltage of T2 D1, that is VBA. So from this point you have to see how the VBA is changing up to 2 pi. Again after 2 pi, on the same leg, two devices are conducting T2 D2. The output voltage is 0. At this point again T2 will be off because the current is coming to the 0. The load is subjected to the voltage in a load, that is the same circuit operation will be repeating. If we draw the load current waveform from alpha to pi, you have to increase the load current. After pi, you have to decrease the load current to the 0. From beta to pi plus alpha, no device is conducting. So the load current becomes a 0. Again same, increase and decrease it. If you draw the source current waveform from alpha to pi, this load current is supplied by the source, that is positive. So here draw in a positive. When freewheeling action taken place, source is not supplying any current, so the source current becomes 0. In this duration also source is not supplying any current. Again from this point to this point, source is supplying a current through the T2 D1, but it is negative. You take the same waveform in a negative. Again from this point to this point, source is not supplying any current. Complete the waveform. Now we are going to find out the average output voltage. Alpha to pi, this is area. This area we are going to calculate by means of integration. Now this area is a rectangle. This length becomes a pi plus alpha minus beta. This height is equal to the E. So 1 by pi integral alpha to pi Vm sin omega t d omega t plus pi plus alpha minus beta into E. Complete this integration. We are getting the expression for the average output voltage, this one, for the discontinuous load current. Now we are going to keep the same circuit operation in the table form. Alpha to pi, T1 D2 is conducting, the output voltage is VAB. Pi to beta, T1 D1 is conducting and the same leg two devices are conducting, freewheeling action taken place, so output voltage 0. Beta to pi plus alpha, no device is conducting, the output voltage is equal to E. The same thing will be repeating for the remaining cycles also. Thank you very much for watching this video.